In the 1970s, when I came to the University of Waikato, it was a very exciting time in the earth sciences because we had two revolutions that were going on that were converging. The development of the new concept of plate tectonics and the new understandings about climate change. I realised that developing a good understanding of the geology of a region was really about understanding vertical crustal motions. I combined with Dr. Gillian Turner in the physics department at Victoria University of Wellington, and there they had purchased a new cryogenic magnetometer. We set off to obtain core samples from the rocks exposed in the coastal section north of Wanganui City, and for the first time worked out the age of the Bruns-Mariana boundary in the Southern Hemisphere. We were able to actually link materials on land with the record in the deep ocean. Around 1980, I headed off to the University of Melbourne to work with the group which was leading the development of fission track dating. We undertook an initial study of two transects through the Southern Alps in order to date the timing of the uplift of the mountain range, about which previously there was no information. Our results enabled us to actually map out the extent of uplift of the Southern Alps. And this showed that there's been about 25 kilometres of uplift along the western margin of the Southern Alps, with the amount of uplift decreasing exponentially towards the foothills of Canterbury. The question is where a lot of those materials have gone. Well, they've been dispersed to the surrounding sedimentary basins. One of the basins that contains the sediment is the Southwestland Basin, and this is mainly offshore of the narrow strip of Southwestland. I realised that the reason we have such a narrow strip of land there has to do with the effect of the Pacific plate loading the Australia plate. We showed that the sediment thickness increases towards the coastline, which is rather unusual. Much of the sediment that's gone down the western side of the Southern Alps has gone into the Taranaki Basin, and this has been a very important feature because it's the sediment loading that's occurred which has caused the burial and heating of the coal measures that had previously been deposited in Taranaki Basin, and it's that heating which has evolved the oil and gas from those coal measures. And so we've been interested in developing information about the architecture of the fill of those sedimentary basins, the character of the sediments, and what we call the paleogeography of the basin. We have mapped at fine detail more or less the whole of the King Country region and the North Wanganui Basin, and across into the eastern margin of Taranaki Basin where a lot of the exploration has been taking place. What I've found in my career is that success in science really comes down to three main areas. One is relationships with people, the support of an institution, and the University of Waikato has been a great institution in this regard, and resources in order to fund the operational aspects of our work and the employment of researchers within one's research group.